Hello and welcome to the 3-minute preview of our paper Enabling RTK Positioning Under Jamming. My name is Tobias Bamberg. Let's start with a short motivation. A lot of GNSS applications demand high position accuracy, for example, surveying. Real-time kinematics and precise point positioning can fulfill this demand. However, that works fine as long as there is no interference, and interference is an issue in GNSS, so we need to have some interference mitigation. One promising approach is an antenna array. Now the question arises, can carrier phase positioning and multi-antenna array positioning be combined? What is the idea behind an antenna array? Instead of one antenna, we have more antennas. These antennas are spatially close to each other, so they see slightly different phases of the incoming signals, simply because of the different positions. Now we can adapt these phases and superpose the signals constructive or destructive in order to amplify wanted signals or to suppress unwanted signals. But because we manipulate the phase, we induce some phase offset. For spatial signal processing, we distinguish two types of approaches. First is the deterministic approach. It requires information about the incoming signal and the receiving system. If we have that, the phase offset can be calculated and corrected. What information are required? The direction of arrival of the incoming signals, the antenna array radiation pattern, and the calibration of the receiver system. The blind approach, on the other hand, does not need preliminary information, but it induces some unknown phase offset. In this research, we will focus on blind approaches because they are less complex. Now we need to compensate for this unknown phase error. The basic idea is to steer the phase based on the previous weighting vector. For that, we need two assumptions. The previous weighting vector did not induce a phase error. And the second assumption is that the direction of arrival of the incoming signal does not change, so that we have a quasi-static receiver. I would like to show you some experimental results. So we transmitted a jamming signal on a static antenna array receiver and tried to get an RTK position solution. First, we used only one element of this antenna array to get the position solution. You can see as soon as the jammer is activated, indicated by the red bars, we no longer can estimate a position solution. If we use the spatial signal processing of the antenna array to mitigate the jamming signal, we can maintain a position result. However, the position solution drifts away. And finally, if we use our phase compensation algorithm, the position stays almost constant as it should be. Are you interested? Then please take a look at our paper, and if you have any questions, contact me. Thank you.